In this Code Robots demo, we're going to use Snyk to find vulnerabilities in our microservices-based application. We have a React-based web front end that communicates with a Node-based web gateway that makes calls to 3 Spring Boot-based backend services. We're going to use Snyk to fix the 4 vulnerabilities in our web gateway. We're going to use Atomist to fix the 20 vulnerabilities in our Java backend. This is a Snyk dashboard for the potentially vulnerable application components that are running in Cloud Foundry right now. As you can see, we have 24 vulnerabilities that we need to address. We're going to go ahead and address the node vulnerabilities first. Snyk has built-in integration with GitHub. We're going to use that to fix our node vulnerabilities. So we click on the GitHub view of this application. We have the 4 vulnerabilities. We double click on the package JSON associated with this node-based application. Snyk gives us the ability to open a fixed pull request. We'll go ahead and do that. As you can see, all of the high-level vulnerabilities can be addressed with this pull request and also some others as well. So we'll go ahead and open a pull request. It looks like not only has that pull request been submitted, but it's also hit our Slack channel. So we've got Atomist letting us know that Snyk has attempted to send a pull request our way. We're going to go ahead and enable auto merge for this pull request. Now let's go to our pull request in GitHub. As we can see, we approved auto merge, and now we're just going to merge the pull request. With any luck, we should have a patched and functional version of our node-based gateway. Now let's change gears and address the issues in our Java apps. For this, we're going to use Atomist, and that's because the changes that we need to make cannot be applied automatically by Snyk. So we're going to shift gears, and we're going to start Atomist up. So we've got a software delivery machine that's got our customizations for this update in place. What we're going to do is we're basically going to upgrade Spring Boot 1.5 to Spring Boot 2.1.3 for the projects that have vulnerabilities. That's going to address the issue. Now that we've got our software delivery machine started, we're going to run a few Atomist commands. The first command is we're going to clone our repo. So this is the direct URL to our repo. We're going to do an Atomist clone. What this will do is that'll give us a local working copy that we can run our automations on. The next thing we're going to do is we're going to run Atomist try to upgrade Spring Boot. What this is going to do is this is going to upgrade the Spring Boot version in all of the projects that have an older version. And it looks like that ran. And the next thing we're going to do is we're going to actually push this to our GitHub repo. So we're going to do Atomist push upgrade. These are custom commands that we created with custom software delivery machine logic so that we could address this issue. So we have a GitHub branch and push to the repo. As you can see, Atomist has told us via Slack that there is a new pull request for the Spring Boot upgrade. So we're going to go ahead and raise the PR. And now some checks are being run. So we're actually seeing that Atomist is communicating with Snyk. Snyk's running vulnerability checks against the projects to make sure that we've addressed the issues. It does flag that some checks were not successful, so it looks like we're going to have to go in and check and see what Snyk found. And obviously, there are still some issues with respect to vulnerabilities, but the major vulnerabilities, the high-level vulnerabilities, we've addressed. So what we're going to do is we're going to go ahead and merge this pull request. And with any luck, all of the high-level vulnerabilities have been addressed. Before the moment of truth, let's go ahead and review the changes that we made. Atomist upgraded Spring Boot from version 1.5.0 to 2.1.3 in 2 POM files. These are the 2 backend projects that had 10 vulnerabilities. Snyk upgraded several node packages from a vulnerable version to a non-vulnerable version. We'll go to the Snyk dashboard to check out the applications that are deployed to Pivotal Cloud Foundry. Sure enough, all of the high-level vulnerabilities are gone. This is great. That means that our security vulnerability pull requests were successful. Now, we just need to verify that the application actually works. So if we go to our Pivotal Web Services dashboard, we see that all of the apps are running in the production space. Very good. We'll go ahead and click on the user interface and give it a spin. We'll go ahead and log in. And voila, our application does indeed work. We were able to use Snyk and Atomist as code robots to patch vulnerabilities in our microservices-based application.